And we are live. All right. So we're looking at the Chapter 3 test homework. So here we're looking at number 7 and number 27. So in the first one here, we're looking to try and solve this using any algebraic method. So when it says any algebraic method, here what we're really looking for is either substitution or we could be doing elimination. I don't know any other method that you folks may have sometimes heard this referred to as, but sometimes it's referred to as combination. So elimination, combination, or we can do substitution. So now in terms of solving this thing, I would really just look at the problem. If I don't see one of my variables that is very clearly by itself, or I can quickly and easily get by itself, I'm gonna say, nope, I'm doing elimination. So I don't know, 7 times out of 10, I'd say I'm probably doing elimination right out of the gate. But substitution can sometimes be a little bit easier. So for this one here, I would say we do have a candidate for substitution. On the first equation, we have 7x and then just y by itself, and then we have this negative 17. So if I wanted to get this y by itself and then substitute in right here, I absolutely could do that. So that's a good candidate for substitution. On the bottom here, again, you can always do substitution. It's just that fractions usually throw people off. So I'm going to try and avoid it where possible. So here I see that I have 3, 10, and 24. Nothing really to simplify nicely here. So I only have y as a candidate, and it's only from the top equation. Now, I personally would probably do more like the elimination for most of these. If I want to do elimination, I could use the 7 and the 3 and try and get a common multiple between the two, which would be 21. Or I could use the 1 and the negative 10. So personally, I see this and say, okay, multiply the top equation by 10, and I'm good to go. So again, we can do one or the other. It doesn't really matter. I'll show you both here just so we can have like a total explanation for both methods. So we'll do substitution in orange here. For substitution, I'll get the y by itself. So this is going to become y equals negative 7x minus 17. And now I take that y and I plug it into this equation. So I'm going to just jot this equation down in yellow here, 3x minus 10, and I'm going to leave this open because that's my y thing. And we know that thing equals, whoops, not 4, 24. And so now this is my negative 7x minus, that's not the best, there we go, minus 17, there we go. So looking at this here, I'm going to do my distribution, and I'm going to go ahead and solve. So this 3x is just saying 3x. My negative 10x is going to both of these terms, so I'm going to get plus 70x, and over here I'm going to get plus 170 equals, now here's my 24. So again, I'm going to get all of my x's together, and I'm going to get all of my constants together. So on the left side here, I'm going to get 73x. I'm going to subtract off 170 from both sides. And so I get 73x equals negative 146 here, divide by 73, divide by 73, and I get my answer, x equals, well, that's not the best equal sign we've ever done, but we'll fix that. There we go. So x equals negative 2. Once I know my x, I can plug it in to solve for my y. So I can plug it into either of these equations. I'm just going to pick the top one because it's on top, so why not? So here it was 7x plus, oops, there we go, plus y equals negative 17. But now we know that x is negative 2, so we're going to say 7 times negative 2 plus y equals negative 17. Here we get negative 14 plus y equals negative 17. I'm going to add 14 to both sides. So y is going to equal negative 3. We want to take our two answers, plug them back into both of our equations just to verify to make sure we did everything correctly, and it works. The next method we could do is we could do elimination on this. So if I did elimination, I'm just going to copy it one more time. So if I wanted to do the elimination method, I would say I need to add these two equations up such that one of the variables cancel. I'm going to try and go for y's because it's less work than going for x's. Please don't tell anybody, but I'm incredibly lazy, so I want to do the least amount of work possible. The necessary step to do that is that I need this top equation to multiply by 10. So I have 10y on top and negative 10y on the bottom, thus canceling them out. So this is going to become 70x plus 10y equals negative 170. I'm just going to copy my other equation down below here. I'm just going to add these things up. So here we'll get 3x minus 10y equals 24. And now I would actually go through the process of adding them up. Added this gives me 73x. These cancel off by design, equals negative 146. And I'll stop here because this is all the work we just already did. So again, once we get to this point, we solve for our x variable is negative 2, plug it back in, get the y variable is negative 3, just like we did before. So this is the setup for this one, and then we just follow it through the same as the other. Any questions on this one? Good, good. All right. Yes, the homework is due today, Drew. I believe, I'd have to check the schedule, but yeah, I think so. Okay, so here we have an appliance store is ordering chest freezers, and they also have upright freezers. So one chest freezer costs $250, delivers a $40 profit. Upright freezer is $400 with a $60 profit. So I'm just going to jot that information down off to the side here. We have chest, the cost, and the profit. So the cost is $250, profit is $40. We have upright, and my handwriting is phenomenal. Cost here is $400. Profit is, whoops, that's not very good, 400, but there we go. Profit is $60. And from here, based on previous sales, manager expects to sell at least, so we're going to sell at least 100 freezers, okay? So what this is meaning is that basically the x plus y here is going to be greater than or equal to 100, okay? So I'm going to start naming variables. I'm going to call my chest freezers, the number of chest freezers I have, x, and I'm going to call the number of upright freezers I have, y. So again, if you want to call it like C and U for like chest and upright, that's totally fine. I'm just using x and y. We're going to set it up on an XY, coordinate plane anyway, so this typically makes a little bit more sense for folks, but if you want to keep it C and U, that'd be totally fine. So we're going to sell at least 100, so what that means is that x plus y is going to be greater than or equal to 100. So that's the first part I'm getting from here based on previous sales, blah, blah, blah. The total profit must be at least blah, blah, blah. All right, so for the total profit part, do it in blue here. So we want the profit to be I don't want to write at least because more writing, but whatever. I'll write it out. So at least 4,800. And so now we want to find the least number of each type of freezer the manager should order to minimize cost. Okay, so now I want to talk about the minimize of cost. Well, that's where I'm going to look at this cost right here. So my cost function for this is going to be 250x plus 400y. So this is the thing that I want to minimize here. Profit needs to be at least 4,800. So what that means is that I've got profit for X was 40. So 40 times the number that I sell plus, plus this Y thing must be greater than or equal to 4,800. The Y portion of this being 60Y. So again, for each of these that I sell, right, for every chest freezer, I'm going to make 40 bucks in profit. For every upright freezer, I'm going to make 60 bucks in profit. So 40x plus 60y needs to be greater than or equal to 4,800. That's the profit. So profit must be this. We have the total number of sales, need to be at least 100 units. And then we have our cost or objective function based on the price of each of these different freezers. So now we basically have everything that we need. I'm wondering if I want to do this in Desmos or something, because there's no way I'm going to be able to like accurately do a good picture for you. So I'll show you one resource here, which is a cool one. Desmos is nice, Wolfram Alpha is nice. There's a bunch of other different ones, but we'll play with Desmos for now. And do graphing calculator stuff. So the first equation that we have is going to be this x plus y greater than or equal 100. I'm going to say x plus y. And then I think I have to use a little keyboard down here to insert the right signage. And unfortunately, my Zoom controls are in the way. So I don't think you guys can see this on the video, but those that are in here with me, they know I'm trying to finagle it in such a way that I can do what I need to, but also see what I got to do. And then the next equation here, blah, 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 40x plus 60y. So 40x plus 60y be greater than or equal to 4,800. So again, with this one, if I wanted to simplify and just say 4x plus 6y greater than or equal to 480, just from dividing everything by 10, we could. And we can also divide further from there. I'm just going to leave it. Appears to be another formula. Now I want to look at more like real constraints. Real constraints will only start talking about like what can actually happen. Like I've yet to meet a person. Everybody exists. Either I can buy my needs to be greater than or equal to 0. Have a negative, and my y. So y is greater than or equal to 0. And these are my real constraints. Now I'll jump back into Desmos here. I'm going to say x is greater than or equal to 0. And the last one here is we have y is greater than or equal to 0. All right, now we have everything we want. Let's shrink this. Let's back up a little bit. We're going to have to back up a fairly significant amount, but that's okay. We're going to pull this around. And so now I want to see, well, what points do I care about? The points that I care about are going to have to work for all of my different functions. So for all the different functions, what we're basically saying is if I were to just highlight one of these things, so we can kind of like play on off with the toggle button here to see where it is. So I'm saying for the blue, it's where the line is and everything above. For the red, it's where the line is and everything above. For the green, it's where the line is and everything above. For the purples, where the line is and everything above, or sorry, for the greens, everything to the right, not above. So as I look at these things, I need to be above for both these lines, above for the horizontal line here, and to the right of this line here. So now I start defining my significant points. So this is one of my significant points right here, this 0, 100. So I'm going to call this point A. So the 0, 100 is what I'm going to call point A. Let's do it in, we just use this fancy purple color? We did. Let's use brown. So my point A is going to be 0, 100. And you can do this by intersecting lines too. You don't need like a fancy graph like this to do it. The next point I'm looking at is 60, 40. I'm going to call that one B. And the third point that I care about here is going to be 100, 0. Call that C. And so now if I think about, well, what's the maximum profit I can make, right? If I was like a business, I'm trying to maximize profit, I would literally sell an infinite number of freezers, right? I would literally deplete the entire planet and start mining stars and asteroids and stuff for raw material to make more freezers, but that's not possible. And especially not possible with what we're really interested in, which is to minimize our cost, right? In business, it's not always the most important thing to make the most money, it's to make the most profit. So this is my cost function here. So the cost of my, was it chest freezer stand? Yeah, chest freezer was 250 and the upright freezer was 400. So when I look at this thing, I need to also factor that in. So when I'm looking at this, I'm trying to solve for what my minimum is going to be. So I'm going to plug in for each of these different points. So if I go out to maximum, right, infinity, infinity, this is surely not going to be a minimum, right? This problem has no minimum. So just in terms of like the bounded region here, we can see, if I zoom out really far, all this like very shaded stuff here is just going to be continuing to positive and infinity for my y's and my x's. That's not going to be what we're looking for. So let's plug and chug from here. 0. So I'll write the first one out and then I'll kind of like just jump through them. So it's 250x, which is 0 for this one, plus 400 y for this one, which is 100, equals, so anything times 0 is 0. So I have 400 times 100, so I'm just going to take my 400 and slap 2 more zeros on there. Throw a little comma just to make it a little bit more clear, and we get 40,000 for this first one. For the next one here, we have 60, 40. So I'm going to do 60 times my 250 plus 40 times my 400, and that gives me 31,000. And for the last one here, I'm going to do 100 times my 250, 0 times my 400. This is going to be 25,000. So in terms of minimizing my cost, okay, this is going to minimize my cost here. So for the answer, in terms of what we want to produce, or what we want to sell, excuse me, is we want to sell 100 of the, what is it, chest freezers. So that's going to put us on our sales benchmark. It's going to be the number of expected along with minimizing the cost. Any questions on that one?
Will there be a question like that?
Will there be a question like this on a test?
Yeah.
Like this? Yes. Maybe not to this extent. So one of the things too is like on an exam, I typically like to test like the more reasonable level of difficulty. I don't like to put like the hardest of hard on there. When I think about it, typically I think on like an individual night when we're digging into the homework, that's when we're like the most in depth. Whereas the summative assessment is kind of just like grabbing a little bit of everything. So it's a lot of different things, but not like the deepest level from each of them, if that makes sense. Good with this one? Perfect. All right, I will stop our recording here.